morning, my YouTube viewers. It is Crystal here. I'm making another video. This is going to be on the coursework for Module 2 of Probability and Chance in Mathematics. And what I did was I took all of the coursework and I converted it to Excel so you can know how to do it in Excel if you want to know how to do it in Excel. And the reason why is because I use Excel at my day job, number one. And two, because I pay to receive Excel. I pay to get Excel. And then, so since I'm paying for Excel, I may as well use it as much as I possibly can. So, this is Module 2. My last video was Module 1, if you want to go back and look at the last video. And this particular video is going to be on coins. So we're going to look at the probability of tossing coin 3 times and getting 2 heads. So the number of trials is 3. And then the number of successes that you're looking for is 2. And then the probability of getting a head is 0.5 or 50%. And the probability of getting a tail is 1 minus p is 50% as well. So the formula for combinations is factorial b3 divided by factorial b4 times factorial b3 minus b4. And so your probability is going to be a combination of b3, b4 times b5 to the power of 2 times b6 to the power of b3 minus b4, and that gives you a probability of 0.375. So that's the probability that you'll get if you toss a coin 3 times and you get 2 heads. So the next exercise that we had was drawing pins and possibility of drawing 3 pins and getting 2 ups. So the number of trials is 3. The number of successes is 2. Probability of heads, we'll just say probability of tops. Probability of ups is 0.25, and probability of downs is 0.75, and the probability of downs is 1 minus probability of ups. Formula for combinations is equals factorial b3 divided by factorial b4 times factorial b3 minus b4. So that gives you a 3. And then your probability is a combine b3, b4 times b5 to the power of 2 times b6 to the power of b3 minus b4, and so your probability is 14%. So now the next thing we're going to look at is numbers. So we're going to look at a problem using binomial distribution. So 10 values of x are chosen. What is the probability of choosing x equals 2 4 times? So I just made a little table of x, 1, 2, 3, 4, and the probability of x equals 1 is 0.2. A probability of x equals 2 is 0.3. A probability of x equals 4 is 0.4, and a probability of x equals 4 is 0.1. So we have the number of trials is 10, and so the number of successes is 4. So probability of getting a 2 equals C5, so at 0.3, and probability of not 2 is 1 minus B9 is 0.7. So you have your probability equals combine B7, comma, B8 times B9 to the power of B8 times B10 to the power of B7 minus B8. And so your probability is 0.2. So that's your probability of choosing x equals 2 4 times. So now the question that we're going to be working on is job vacancies. So people are interviewing for 5 vacancies. The probability of any candidate getting a job is 0.3. What is the probability that the final candidate is selected for the 12th interview? So you have N, which is the number of vacancies prior to the 12th, is 11. You have R is 5, that's your number of vacancies. You have your probability of success is 0.3, and probability of failure is 1 minus 0.3, which is 0.7. And then your probability equals combine B5, comma, B6 minus 1 times B7 to the power of B6 times B8 to the power of B5 plus 1 minus B6. And your probability is 0.06604. So now what we're going to do is we're going to look at the normal distribution. So suppose the population has a mean of 160 and a standard deviation of 20. What is the probability of getting 190? So mu, that's your mean, is 160. And sigma, which is your standard deviation, is 20. And x is the value that you're looking for, as 190. And your z-score is B6 minus B4 divided by B5. And your z-score is 1.5. So probability of 190 equals norm.dist, brackets B6, comma, B4, comma, B5, comma, true, which means it's a CDF, a cumulative distribution function. So you have your probability of greater than 190, which is 1 minus norm.dist, brackets B6, comma, B4, comma, B5, comma, true. So that's the answer to that question. The probability of 190 is 0.933. So we have another question with the random variable. Is random variable x follows a normal distribution with x bar equals 60 and standard deviation equals 5. Find P x is less than or equal to 68. So mu is your mean, is 60. And sigma, which is your standard deviation, is 5. And x, which is the value that we're looking for, is 68. So the probability is norm.dist, brackets, B16, comma, B14, comma, B15, and true, which means you get your cumulative distribution function. So now the next question we have is a random variable x follows a normal distribution with x bar equals 60 and standard deviation equals 5, and find probability of 52 is less than or equal to x is less than or equal to 68. So your mean is 60, your standard deviation is 5, your lower bound is 52 and your upper bound is 68. So we find the probability of the upper bound, which is norm.dist brackets B26, comma, B23, comma, B24, and true, which means it gets your CDF. And then you find your probability of your lower bound. So norm.dist brackets B25, comma, B23, comma, B24, and true. So you get your probability of your lower bound. And then we're going to calculate the overall probability equals B28 minus B29. So you get a value of 0.89. So we have our last question with regarding the normal distribution. A random variable x follows a normal distribution with a mean x bar equals 60 and standard deviation is 5. And then it's done that all over again, so I'm not going to do it. I think that what has happened is one of the exercise questions became one of the assessment questions. So I'm not going to do that because it's exactly the same. So there's no point going over the exactly the same material 2 times. But what happened was one of the assessment questions is exactly what was happening in the course material. So we just deleted that. So that's it for the normal distribution. So the next thing we're going to look at is the binomial distribution. So with the binomial distribution, you have a number of trials is 5. You have a probability of success is 0.4. And then so you've got your 5 trials, 0 to 5. And then you've got your binom dist, brackets A4, comma, B1, comma, B2, and false means that you get your probability distribution function. And then so we take that and then we copy it down to the other 5 values. And then now what we're going to do is we're going to calculate the probability, the XP. So A4 times B4 is 0. And then we're going to copy that down to the other 5. And then what we do is we sum it, C4 to C9, and so your mean is 2. And so that was one of the exercises that we did for the binomial distribution. And that was one of the exercises that he did in Excel. So he showed like 1 or 2 things in Excel and everything else was done by hand. So that concludes all of the work that we did in Module 2. And so the next video that I make is going to be the assessment, the questions in the assessment will be the next video. So this concludes this video. So thank you so much for watching this video. You've got the coursework for Module 2 converted to Excel so you can see how to do it in Excel. If you like my video, please like and subscribe. And I will be communicating with you in the next video where we'll cover the questions in the assessment converted to Excel. So thank you again for watching my video.